but this activity is going to count as our graphs, our notes for the vertical asymptotes and horizontal asymptotes as limits. So if you have any questions on these, please make sure you guys raise your hands. But I want to do this through Delta just so we have some fairly accurate graphs here. And vertical asymptotes and horizontal asymptotes we've talked about before and why you get those things. We did a lot of that with rational functions. These functions are not necessarily rational. However, they do have asymptotes. So what you want to do is look at the end behavior. This end behavior to the right appears to continue to go up, and that's what that arrow really means. If it changed directions, it would need to have a different arrow on, a different spot on there. But if the arrow is indicated, that means that it continues in that direction and does not change. If I look at the left side here, this appears to be kind of tailing off right here. And that leads me to believe that there is a horizontal asymptote right here, a horizontal line at y equals -5. So I would say that there is one horizontal asymptote at y equals -5. So you're going to choose between vertical and horizontal. Sometimes there's both. And then what type of asymptote they are. Now, why do I think that? Because as our x's go to -infinity, meaning our inputs go to -infinity, our outputs go to -5. And these are going to be similar to your homework. So looking at this function, I have a suspicion there is a vertical asymptote here, okay, because they both explode up to infinity. I don't think there are any horizontal asymptotes because this appears to continue to go downward. This appears to continue to go upward, but I do think that there would be a vertical asymptote here. And so I'm going to say there is one vertical asymptote at x equals 1. Okay, and I'll just give you a second to look at that. Right here is where I'm thinking, and they're integer values. So at x equals 1, there appears to be a vertical asymptote because as x approaches 1, f of x approaches infinity. As my x goes to 1, as my inputs go to 1, my outputs keep going up to infinity. All right, now this one, I think I have a vertical asymptote here and a horizontal asymptote here. Okay, so you have to be kind of careful. Sometimes there's both. I think in this case, I have two asymptotes. So I'll do the horizontal one first. I think I have a horizontal asymptote at y equals 2. So horizontal at y equals 2. Because as x goes to infinity, f of x equals 2. And now the vertical asymptote, I think I have a vertical asymptote here at x equals 5. Because as x goes to 5, our outputs go to -infinity. They're going down. So I'll give you a second to look at that. Again, it's horizontal right here at y equals 2, because as x goes to infinity, our y's go to 2. And right here is a vertical asymptote at x equals 5, because as x goes to 5, our outputs or y values go to -infinity. I'll do one more. And then, of course, I can answer any questions that you might have. But this is a good one because it looks like I have two vertical asymptotes and one horizontal asymptote. I do not have a horizontal asymptote down here because that appears to just continue to go downward. So I have a vertical here, I have a vertical here, and I have a horizontal here. So I have a total of 3 asymptotes. I'll do the horizontal one first. I just find those easier. So horizontal asymptote at y equals -3. Because as x goes to infinity, my y's go to -3. So as x goes to infinity, my f of x, or my y's, go to -3. Then I have 2 vertical asymptotes, so I'll change both of those to vertical. I'll do the left one first. First at x equals -1, because as x goes to -1, those are both going up to infinity, so f of x goes to infinity. And I think I also have a vertical one at 6, so at x equals 6, because as x goes to infinity, f of x equals 6. Oh, what did I mess up here? Oh, I think I might have said it wrong, but I'm sorry, guys. I messed this one up, of course. As x goes to 6, f of x goes to infinity. They both continue to go up towards positive infinity. Okay? Sorry, I messed that one up. Do you guys have any questions for me?
I have a question.
Yeah.
So you see how like there are two, like when you said -1,
Mhm.
like how come there's 2 different lines going up, but you just counted them as one?
Well, it's all one function. And so the function is discontinuous here, meaning this is kind of where you think about left side and right side. So on the left side of -1, the function is going up towards infinity. And on the right side of -1, the function is going up towards infinity. And so it is all one function, and they're both going towards the same spot. And so that is your limit. Your limit as x approaches -1 would be infinity, because f of x goes to infinity.
Okay, thank you.
That makes sense. Other questions? Thank you, Sidika. Good question.